This is part 4, how to improve demand control ventilation. If you actually had used this strategy, which a lot of folks have used it, but not enough of them, you'd find that during COVID, you'd be able to easily switch over from DCV to ventilation for what I'll call pandemic mode, okay? This is just a solution and then that I think we should do going forward for DCV. It still will save energy, but it also will make sure that you provide proper ventilation. I think that's what's really important. So when we talk about DCV, it's basically required by standard 90.1, and it's also required by a lot of your local energy codes, okay? And demand control ventilation is required for spaces larger than 500 square feet and with a design occupancy for ventilation of greater than 25 people per 1,000 square feet of floor area. Currently there's some public review documents out that actually wants to expand the scope of DCV, which I don't have a problem with expanding the scope of DCV if we do it right. The problem I have is when you look at this, nothing here says that DCV means maintain and control CO2 levels, right? And the fact of the matter is DCV is defined, it's defined in standard 62, and it's under the ventilation rate procedure. It's not under the indoor air quality procedure, and that should become evident to you as well as I go forward in this, why it's under the ventilation rate procedure, okay? But yet I have people all over the place doing things with the IQ procedure and reducing ventilation rates with filtration and air cleaning and then still doing CO2 DCV. There's just way too much misunderstanding out there. So hopefully this helps you out. So under standard 62, dynamic reset is kind of a broad way to, a broad description for adjusting the outdoor air. And demand control ventilation is a subset of dynamic reset. And it says DCV shall be permitted as an optional means of dynamic reset. And here's what DCV is. For DCV zones in the occupied mode, breathing zone outdoor airflow shall be reset in response to current population. So not CO2 level, but current population, all right? And there's a reason for that, okay? It's because the ventilation rates are based on the number of people in the space, nothing to do with the CO2 level. And I want to make sure you understand it. I think some of you may have already gotten to understand this a little bit from the last presentation, but let's see how this goes going forward, all right? So if you want to find out if any method you use for DCV complies with standard 62, you clearly need to know and show that you provided a breathing zone outdoor airflow. Now, standard 62 is normally used as a design standard, and you base the calculations on the number of people in the ventilation zone during typical usage. But once you're operating in DCV, you've really made standard 62 into an operational standard. And so now you have to replace it to the current population of the ventilation zone, okay? And so we would calculate the breathing zone outdoor air for the current population. And we're going to stick with just single zone today because multi-zone's considerably more complicated. And if we can't get past single zone, there's no point in talking about multi-zone. So if you wanted to know if your method complied with standard 62, you look at the population of the ventilation zone during actual usage, you'd calculate the outdoor airflow rate required based on standard 62's ventilation rate procedure, and you would demonstrate that you at least provided the minimum ventilation. That's it, it's that simple. So the first thing I say to most people, it's like, why are we doing this with CO2? Why aren't we just counting the occupants? You know, why aren't we doing that? I mean, it's easy. I mean, we have counters. We make a counter. We have counters that will count how many people go into a meeting room or a conference room or a classroom. You know, you go into a big arena or something like a big volume of space where the lag is huge. You know, why aren't you using your turnstiles, if it's still got mechanical turnstiles, or your electronic ticket counting systems? You know how many people are coming in. You know how many are in there. You know, we could have in offices RFID card counting systems. We could have video imaging counting systems in casinos. Theaters, they're the ones that crack me up probably more than any single one, because you have a movie theater, for instance, and you say, you know, oh, well, you know, it's not a really popular movie, so people are going to go in. Well, they're doing CO2 ventilation control. The CO2 level doesn't get high enough to do anything until the movie's over and people have left. How's that going to work out for you? Okay, you're totally underventilating the movie theater, all right? And yet you have a point of sale system that tells you how many people are in a theater, when they went in and when they're going to leave. Why aren't you using that? You know why you're not using it? You don't realize that's what DCV is, okay? And there's other ways, okay? And I always say to all good engineers, I'm like, look, this is time to think outside the box. What is the matter? Don't be a sheeple, okay? And just follow what everybody else is doing. Think about what's going on and what we need to do it right. This would be demand control ventilation, all right? And so when you get into population-based ventilation control, it's pretty simple. You measure the population. I'm saying something like our census counter, but it could be anything that you're using to measure the population, and then you calculate the outside air set point based on standard 62 or whatever it is you're using, okay? Maybe you're not using standard 62. The first thing I always tell people is set limits. Set an outdoor air min and an outdoor air max. Well, the max is most likely based on the maximum expected population, but the min could be the minimum expected population. It could be one person, or it could be your local exhausts, okay? But there is a range that you want to be within. And then you output the flow set point, and it goes into whatever your outside air, goes into your outdoor air control loop that then goes to whatever your strategy is. You measure the outside air and you maintain it for that set point. That's DCV, all right? And, when you look at it, I look at, hey, on a classroom, what would your error bands look like if you had plus or minus 3 counting over the entire range? So at 35, you were plus or minus 3, and at 0 or 1, you were plus or minus 3. Okay, and it's pretty tight. It doesn't look bad at all. Okay, and so that's direct counting, ventilation control. And there's no lag error. It's what it is. You got people in, you got people out. I cannot understand it other than there are people out there that have a reason and an agenda for doing what they're doing. Okay, so. Getting down to this reason or agenda, you may have to use CO2 to satisfy your energy code. It's like, well, okay, if you do, let's at least make it better. Okay, can I improve it? The answer is yes, we can improve it. So the first thing you need to do, which is why I want to see Addendum D get approved, is you need to account for the activity level and the age. Now, if you have spaces that have wide variability in activity level and ages, it's going to be hard to do it, okay, with CO2. All right, but assuming you can do it, you're going to be able to get to some expected activity level, all right? And then what we're going to do here is now we have to set limits to offset the errors of the measurement. The CO2 measurement error, the drift of the sensor, the placement of the sensor, all of these things affect its accuracy. The outdoor CO2 level variability, all of these things affect it. There's no reason for us to go above the outdoor air max, and we need to set an outdoor air min, particularly if there's a local exhaust that we have to be concerned with. So we have to get rid of this wasted energy and thermal comfort issues and our IAQ pressurization problems. So how do most of you do it? Because a lot of you are going to say, well, I do this now. Yeah, I set a min-min and a min-max damper, or I just modulate to maintain my CO2 level. Okay, if you set a min-min and a min-max damper, you're going to end up with all the problems we talked about in part 1. And if you modulate to maintain a constant CO2 level, you're just going to end up particularly overventilating. You're going to be in CO2 alarm. So what you're doing doesn't work, all right? What you really need to do is you need to use an airflow meter in the outdoor air intake. And it's really pretty simple what you're going to do. We're going to, it's basically this cascading control strategy. It's the same kind of logic you use on a VAV box for temperature control. Okay, those of you that know controls will understand that completely, all right? So you measure the CO2 level, you have a CO2 set point, it goes into your CO2 control loop, and the output of that control loop is an airflow set point. Just like I said, with the VAV box for temperature control, temperature goes into a control loop that outputs an airflow set point for your VAV box. It doesn't modulate any dampers directly. Okay, so now we have this updated outdoor air set point. Again, we're going to set our limits. If it's below the min, we're going to set it to the min. If it's above the max, we're going to set it to the max. And if it's anywhere in between, you get the modulation in between. And that goes into your outdoor air control loop again, where you look at the measure the outdoor air, and the output signal of the control loop goes to whatever your control strategy is. It could be as simple as modulating a damper. It could be more complex. And then when you finally plot that, you still have the uncertainty of the single set point CO2 DCV, but at least you've now established these limits. And this is a significant improvement to CO2 DCV. All right. And I mentioned earlier that if you were following something like 189 or the IgCC, you're already there, because you may not have used a flow meter for this, but it says monitoring requirements. Each mechanical ventilation system shall have a permanently installed device to measure the minimum outdoor airflow. And I said there was an exception for constant volume, but that exception doesn't exist when there's DCV. So basically, 189 in the IgCC says you're going to measure the airflow, you're going to monitor it. If you're going to put one in and monitor it, you should do something with it. And what you should do with it when you're doing DCV is what I just described. All right? And is there even a better way? Well, if you're in an area when you're concerned with compliance with standard 62, the answer is yes. When you take a look at the steady state model, when you've already bought into the steady state model when you're doing fixed set point CO2 DCV, okay? And we're going to find that there's some public review information out there now for doing some dynamic control. But when I do my analysis on it and look at the uncertainties, it's not going to really work well. Okay, even though people think it's going to work well, you start looking at CO2 measurement error and you'll realize that no, this isn't really going to work. So you've already bought into this steady state deal. And now that we're measuring VOZ, guess what? The only thing left is people. So you actually can estimate the population. It's going to have the errors associated with steady state, and it's going to have the errors associated with the CO2 measurement. And we could take into consideration the differential term and start to look at estimating the population that way. But anyhow, when you take a look at this, now what you're going to do is I actually think this is easier. You're going to measure the CO2 level in the outdoor air. You're going to calculate or estimate the population. You're going to calculate the standard 62 required outdoor air, and you're going to limit it, as we said earlier, nothing's changing and goes into your outdoor air control loop. And what you end up with is this, something that kind of follows more tightly the required ventilation of standard 62. I think it's something you should consider. Now, in everything I just showed you with DCV, I don't know if you realize this or not, but if we were in this, right now we have a problem with DCV and lowering ventilation. We want to maximize ventilation. You've already got everything you need. You have an outdoor airflow meter, whether you're doing this method, this fixed set point CO2, or the population based, and all you would do is you would set the outdoor air set point to whatever the maximum you wanted to set it to, and that's what you maintain. You'd be done. You could flip from this normal energy saving mode to basically pandemic mode immediately. That's not easy to do for the systems that just simply rely on CO2 levels that you have out there today. So this is another thing I want to show you, because unfortunately, and I've even heard recorded videos from people selling air cleaning systems that tell you to do some of these things, and they clearly do not understand what they're talking about. Okay, so let's just, there's a reason that CO2 and DCV is not part of the indoor air quality procedure. Okay, so let's take a look at this. Let's just say that you are operating under the IQ procedure and you've made some claim, or somebody's told you could reduce the outdoor airflow rate. Again, I personally have some problems with that. because I don't even think that standard 62's ventilation rates are high enough for some spaces under the ventilation rate procedure, never mind reducing it using the indoor air quality procedure. But, you know, what we have here is I'm looking at that this is all associated with the left vertical axis. So this is the VRP required ventilation, which is this dashed green line, right? And now you've made some claim under the IQ procedure that you can reduce that outdoor air, okay? So you're going to reduce it now to this, what's a solid green line with a red dashed line on top of it, okay? So you've made this reduction, all right? Well, think about this now. If this air cleaning system had no effect on the CO2 level, all right, which most of them have no effect. Some of them actually increase it. So if I increase it, it's even going to be worse, all right? But if it has no effect on the CO2 level, you've reduced the outdoor airflow rate. So that means the steady state CO2 level is going to be higher, all right? So it's going to be, it will have increased over what you would have had with the ventilation rate procedure. But you didn't understand how all of this was related, and you still said, well, I'm going to do CO2 DCV at 1,000 parts per million. Well, chances are you design the system for the IQ procedure's ventilation rate, not the VRP's ventilation rate, right? And so what ends up happening is the only way you're going to get the CO2 level down is to increase the ventilation rate above what you think you needed, okay, to get back up to where you were. Okay, so so here's the good part, I guess. If you made a claim under the IQ procedure to reduce the ventilation rates, and you still want to do CO2 DCV, you'd actually be really increasing the ventilation rate. And so good. But if you actually decided that you were going to cut down the sizing of all your equipment because you did this IQ procedure thing, you can't condition the air. You're gonna have a problem, all right? And what about, I skipped over this in the last presentation, but the VRP does not allow DCV when CO2 removal systems are used. Why is that? See, I didn't show you this on the last presentation, but there was an exception, and it said CO2-based DCV shall not be applied in zones with indoor sources of CO2 other than occupants or with CO2 removal mechanisms such as gaseous air cleaners. Why is that? Well, you should understand that by now. You should realize because we're using CO2 as an indirect way to estimate how much outdoor air CFM per person is coming into space based on the relationship between CO2 production of the individuals. That's what you're doing, all right? So anytime you're falsely altering the CO2 level, you've changed the relationship. So what I have here is I'm showing you a system that has filtration that actually effectively removes some of the CO2 level. And I can imagine people that don't understand the relationship between CO2 and ventilation, that think CO2 is a contaminant, saying, wow, what a great idea. I'm going to put this in, I'm going to lower the CO2 levels. Yeah, I'm going to lower the CO2 levels, and now I'm going to simultaneously do CO2 demand control ventilation. But because I've removed it, okay, I have the required ventilation, which is the green, okay. I've maintained the CO2 set point at 1,000 parts per million, but I provided the red dashed line. I so underventilated this space. It's ridiculous, but I'm happy because the CO2 levels are good, and that's all I think matters. People really need to get educated on this, all right? So this is some information that I think is pretty useful. That's the end of part 4. In part 5, we're going to talk about controlling pressurization in buildings. See you in part 5.